Hello, good afternoon everyone.
May nagturo sa akin tungkol dito sa...
Honyo. Honyo. Mr. Honyo. Santiago.
Present po, present. Present po, sir.
Batan.
Present, sir.
Tanjero. Tanhico.
Present, sir.
Perez.
Sir, Irish po, present.
Okay, si Perez.
Present po, sir.
Ras.
Present po.
Gandisela.
Present po.
Abutal. Abutal.
Present.
Silitra. Vidal.
Present po.
Present po.
Paul
Present
Iris.
po, sir.
Judy.
Present, sir.
Sir, present po. Hunyo.
Be present.
Mercado. Mercado. Absent. Orbina. Orbina. Sanchez. Si Orbina absent. Good afternoon everyone. Paki-turn off mo niyo yung aso nyo dyan. When I'm speaking, you just mute your microphone. And if you want to speak, you just turn on. Okay? Alright, so last time, last session, so we have this summary class. Okay, so I want to emphasize this. Can you see the cursor?
Opo. Yes, sir.
Okay, so last session, so we talked about the four processes. Can you still remember what are those processes? So we have the isochoric process, the volume is constant, and we have the isobaric process, the pressure is constant. And ano pa yung dalawa? Can you still remember the two?
Isothermal.
We have isothermal, the temperature is constant. And the last one is the adiabatic. Pag adiabatic class, ano yung constant? So we have four processes. Remember those. Those are very important. And this is the summary of what we had calculated last time. So as you can see here, for the isochoric process, we have the work done is 0. Alright, and we have the delta Q, the change of heat is equal to the change of the internal energy. So you see the values here, they're just the same. So that is from the point A to point B. Alright, and then from point B to point C, if you may refer to the previous PV diagram. So for the BC, this is isobaric process. So we have the total from this formula. The delta Q is equal to the sum of delta U and delta W. So that's why you have here 14 or 1433 joules is just the sum of delta U and delta W. So when you sum up this, so ito yung result. Okay? And then, by the way, BC is the isobaric process. Okay? EB is the isochoric process. BC is isobaric, constant pressure here. CD is also isochoric process. So now we have delta Q equal to delta U. These values are both negative. And again, there's no work done in this process. And for the DA, we have again, this is the isobaric process. What is DA class? Can you remember the DA? Right, so this is adiabatic process. Or what process is this? It's an isobaric process. Pressure is constant. So we got this value here. Okay, so there's the difference because there's a change of work, no? We have a negative 203. From this formula, you just sum up, but all of them are negative. All right. So totals, we have delta Q equal to 202 joules, and there's no internal energy change, 0. So the delta W is equal to 202 joules also. So we can say, class, that the net work, we have here the next, the continuation of our topic, we call it net work for complete cycle is in closed area. Alright, so from this illustration, we have here an example of network complete cycle. So network for complete cycle is in closed area, as you can see in this picture. So from our figure we used last time, again, this is the from here, no, from the bottom to up to this one, the pressure is 1 atmosphere. Then from the bottom up to this point B, so this is 2 atmosphere. All right, and the volume is from here, from this vertical line towards the right, so up to this point, so that is 2 liter. But from here to there, that is 4 liter. Okay, we need to calculate, no, the net work of what we had discussed last session. Okay, so as you can see here, it's just the area, no, the area. So what area is that? Net. When we speak of net work, so after the whole process, ano yung net? Ano yung resultang work na nangyari? Okay, so from this picture, so the network, this refers to this one, class. Alright, this is just the area under this curve. So ito yung net, right? Itong area na to. So to calculate this net, we talk of work, so that is the area under this curve or within this area. And this is calculated as 1 atmosphere, because the height of this triangle is 1 atmosphere. And we have here in terms of volume, the difference of volume. Okay, this is 4 liter minus 2 liter, that is 2. That's why here the area is 1 atmosphere, that is the height of this triangle, then multiplied by the difference of 4 liter and 2 liter, which is 2 liters. Okay, so therefore the net work, so ang net ng work, class, is equivalent to 2 atmosphere L. So minultiply lang natin itong dalawa, so we have 2 atmosphere L, and that is equivalent to 202 joules, because 1 atmosphere is equal to 100. Ano yan, class? Ano equivalent? What is 1 atmosphere? 1 atmosphere is equal to 101,300, right? Okay, this is the network. So from the whole thing, okay, kinuha mo yung nasa taas na bandang, anong natira? Ito yon. Ito yung net. So tinatawag natin net work for a complete cycle. Okay? So I hope you understand this. Now let's proceed to the next part. Okay, so the next part, we have here an example of adiabatic problem. So example number 2, a diatomic gas at 300 Kelvin and 1 atmosphere is compressed adiabatically, decreasing its volume by 1/12. So ibig sabihin, class, ang relationship ng volumes from initial volume to final volume, we have VA equal to 12 VV, meaning the volume at A is equal to 12 times the volume at V. So the question now is, what is the new pressure and temperature? So the gamma there is given as 1.4. This is the solution to this problem, class. Alright, so we have here the illustration. Initially, this is the volume. Alright. Diatomic. So what does it mean, diatomic gas? Anong example ng diatomic gas, class? Anong ni-refer niya ng diatomic gas? Ano ba yan, class? Diatomic gas. You have to remember the terms that you have studied in your chemistry. So we will use that here. Okay, so the gas is compressed. No? The compressed, ibig sabihin, if this is the initial volume, alright, initial volume, when this is compressed, the volume will become smaller. Okay? So decreasing its volume by 1/12. So ito yung original volume, dinecrease natin ng 1/12, or we can say that the volume at A is, itong volume A is 12 times the volume of B. So what is the new pressure and temperature? So this is the problem, and we are given the gamma that is 1.14. Okay, so to solve this problem, here's the solution. So we have here delta Q equal to 0. Why is it delta Q equal to 0, class? Hello? Why is it?
Constant po siya sa adiabatic.
Okay, so sa adiabatic, ang delta Q equal to 0. There's no change of heat, right? So delta Q is equal to 0. That's for adiabatic process. Okay, so we have here an illustration, the PV diagram. So for adiabatic process, we have this formula. Remember this formula, class? We have the product of the pressure at point A. This is our point A. The pressure at this point multiplied by the volume of at this point raised to a power. No, we have the volume raised to a power gamma equivalent to or equal to the pressure at point B multiplied by the volume raised to a power gamma at point B. Alright? So, we have here from adiabatic process, ito yung formula, class. For adiabatic process, remember this. Okay, so we will use that formula. So, again, in this process, delta Q is equal to 0. Let's continue, class. So, focus on your attention in the graph here. So, we have this relationship for the adiabatic. So, bakit nawala yung denominator, class? Why is it here? Originally, galing yan dito, galing sa formula dito. Alright? So, delta Q is equal to 0. So, ano mangyari nito? Ibig sabihin, so the equation turns out to be like this. So, we will use this formula. Okay? So, from this formula, then we can solve for the pressure. We are asked to solve for the pressure at B. So from this formula, okay, so manipulate this, divide both sides by V raised to power gamma, then we have this expression, PV equal to PA raised to VA over VB. So both of the volume is raised to a gamma. So you can put them together and you raise them, the ratio raised to a gamma. Okay, then substituting the given, so PV therefore is equal to PA. We know that VA is equal to 12 VB. That is given in the problem, class. Okay, so you have VB here sa numerator, meron kang VB sa denominator, so that cancels out, or that is equal to 1. So what is left? That is 12 then raised to a power 1.4. So therefore, we got PV is equal to, substituting the pressure at point A, that is 1 atmosphere given the problem, and we have here 12 raised to a power 1.4. So you got the pressure at point B, that is equal to 32.4 atmosphere, or in terms of Pascal, so that is 3,284 kilopascals. Okay, any question, class? Okay, so let's continue. If you have no question, let's continue. Now,
Sir, may question.
okay, yes. Ano yung isang question sa problem class? So we are asked to solve for the
Temperature.
okay, we are asked to solve for the temperature. Okay, so solving for the temperature, again from this relationship, from this formula. Okay, so we solve for the temperature. Now solving for the temperature at point B, then again this is the condition for adiabatic. So we will use this formula, substitute the given and also the calculated result or calculated value. Okay, so pressure at A is 1 atmosphere, and then volume at A, that is 12 VV given in the problem, and then divided by TA. Ang TA natin, temperature at A is 300 degree Kelvin, equals, we have pressure at B, so we have solved this pressure at B, that is 32.4 atmosphere, then volume at V, that is 1 VV, right? Then temperature at B. So here, from the result, we got the TB as the only unknown. So solving it algebraically, then we'll get, so we got the TB equal to 810 Kelvin. Question class. So okay lang, you can manage this, right? How to solve for TB. Okay, so just do it algebraically. Algebra lang yan. Okay, so let's proceed. Now, if for example class, the volume at A equal to 96 centimeter cube, and the volume at, sorry, that is B, yung isa dyan, 8 centimeter cube, then find delta W. Okay, so we're considering the volume, no, at this point B is 8 centimeter cube. Class, can you just hold on, ha? I'll change it. This should be VB. Okay, so it should be VB, yung isa. 8 centimeter cube, and at A, that is 96 centimeter cube. So the question is, find the delta W. So take note, ha, galing pa rin to siya class sa delta Q equal to delta U plus delta W. Then it just happened that delta Q is equal to 0 for adiabatic process. So that's why we have delta W equal to minus delta U. And we know that from our previous discussion, our delta U is also equal to N CV delta T, where the C, that is the molar specific heat of the element or gas. Okay, so this is negative, so this, we can carry this sign, negative sign here. So this is negative, and we know that ano to siya class, yung 21.1, that is the molar specific heat of ano to, anong gas ito? What gas is this? Okay class, do you have any question? So I hope you had followed the
Question.
yes, question. Ito yung mga application na class, ha. This is now the application of this concept. Alright, so next is we have what we call heat engines. Okay, so we have here diagram of a heat engine. We have here the hot reservoir. We call it TH, the temperature here. The H means hot. Then we have here the Q, the hot, Q hot, meron tayong Q cold. Then we have a cold reservoir. and this is what we call TC, means C means cold, and then we have the work out. Okay, this is an ideal heat engines class. Okay, so a heat engine is any device which through a cyclic process. Yung kanina pinakita natin, yung diniscuss natin last time, and also the summary that we have discussed today. So yun ang class na cyclic process. No, galing sa point A, pumunta sa point B, then from point B to point C, from point C to point D, then from point D to point A. So it's a cycle. Okay, so a cyclic process. So engines use that what we call cyclic process. First, the bullet here absorbs heat, Q hot. No, this engine absorbs heat, that is Q hot, and performs work or workout. So ito yung trabaho ng heat engines. Performs yun ng work and rejects heat. So rejects heat, ang i-reject niya yung Q cold. Okay? So this is the overall diagram of ideal heat engines. Now, next is what we call second law of thermodynamics. So tapos na tayo sa first law. Ngayon, we will discuss the second law of thermodynamics. Though wala to siya sa class, wala to siya sa syllabus, but I just want to include this because this is a very important application kasi ito ng thermodynamics. Alright, so again, this is the ideal heat engines. Heat engine diagram. So ito yung reality class for the ideal heat engine. It is impossible to construct an engine that operating in a cycle produces no effect other than the extraction of heat from a reservoir and the performance of an equivalent amount of work. So impossible to siya class na ma-achieve natin. So reference lang natin to siya. Okay? Because this cannot be done. Alright? Now, not only that you can win or you cannot win the first law, you can't even break even the second law. So ito yung reality. Now, for example, we have here a possible engine class. So hot reservoir is produce 400 joules or absorb 400 joules, and 100 joules of work is done and wasted 300 joules. So kung ganito yung setup natin class, I'm sorry, this is a possible engine, right? But if you have this is an impossible engine. So ideal engine, of course, we have an ideal to construct a very efficient engine, but in reality hindi talaga na ma-achieve natin yung 100%. But anyway, this is just a comparison of what is a possible engine and what is an impossible engine. Hello class, can you still hear me? The efficiency of a heat engine is the ratio of net work. So ito yung net work na pinag-usapan natin kanina. Alright? So the efficiency of a heat engine is the ratio of the net work done, which is W, to the heat input, which is QH. So from the picture here on the left side, ito yung QH natin, means hot. Then we have W work. This is the Q cold. Okay? Now, efficiency, ito yung formula ng efficiency class. It's just the ratio of the work, the net work divided by QH. And we know that ang work natin, so from this picture, we have input, right? We have input yung QH, papasok siya, ang W palabas, ang QC palabas. So we can say that W is just QH minus QC. Are you following, class? Are you following? So ang work natin, ang W is just the difference between the input na Q, which is hot, and the output na Q, which is cold. Okay, so efficiency is therefore QH minus QC divided by QH. Now, you can divide QH by QH, that is equal to 1. Then QC divided by QH, so we have QC divided by QH. So therefore, E is equal to 1 minus QC divided by QH. Let's take this example. As you can see from the picture, we have here the heat get into the system, that is 800 joules, and we have work go out from the system, or it produce work, and we have here wasted to the cold reservoir, that is 600 joules. So the problem is something like this, class. An engine absorbs 800 joules and wastes 600 joules of energy every cycle. So what is the efficiency? Okay, ito yung illustration, and we are asked the efficiency of the heat engine. So from the formula, yung QC is the cold, that is yung lumabas, right? So 600, ito yung pumasok, ito yung QH, which is 800. So therefore, efficiency is equal to 25%. Any question, class? If no question, let's proceed. So now the question is, how many joules of work is done? So nakuha natin yung efficiency. We have solved the efficiency. The question is, how many joules of work done? How many joules of work is done? So paano natin i-calculate yung work, class? So kanina in the previous slide, okay, so in this slide we have efficiency is equal to work over QH. Then to answer that question, we have to solve using that formula. Okay? Do you follow, class?
Yes, sir.
The question is, how many joules of work is done? So gamitin mo yung formula dito. Okay, so we have this relationship. Na-solve na natin to. We have this work, we have QH given. This is calculated, so you can solve for the work. Okay? So what is the answer? Okay, let us proceed. So efficiency of an ideal engine, ang tawag nito class is Carnot engine. Efficiency of an ideal engine. Pag ideal siya, ang tawag niya is Carnot engine. So ito yung illustration natin. We have here the heat reservoir, TH. So we have QH, then the work, QC, another reservoir that is for the cold. So T here, C cold, H here is hot. Okay, now for a perfect engine, perfect means ideal engine. For a perfect engine, the quantities Q of heat, or the quantities Q of heat gained and lost are proportional to the absolute temperature T. Proportional siya, class, absolute temperature T. Okay, next we have here the efficiency in terms of an ideal engine or Carnot engine. So the efficiency is given by this formula, E equal to TH minus TC over TH. So we have another formula, class, for efficiency, but this is for an ideal, specific only for an ideal engine. Or, so dividing TH by TH equal to 1, dividing TC by TH, we have TC over TH. So this is the final formula. Now, for example, this is our example number 3. Example number 3, a steam engine absorbs 600. If the actual efficiency is only half of the ideal efficiency, how much work is done during each cycle? Okay, so the solution, again, we will use this formula. Now, for it talks about ideal, ideal efficiency. So we will use the Carnot engine. So ito yung efficiency formula. Okay, substituting the givens. So we got efficiency 40%. So the actual efficiency is only 0.5. So 0.5 times EI equal to 20%. Okay? Then about work. So work, how much work is done during cycle? So using this formula, so cross multiply and substitute the value, we get work equal to 120 joules. In a question, class. The other application, class, is refrigerations. So we have here refrigerators. Ito yung concept niya for the refrigerators. So our refrigerator is an engine operating in reverse. So ano ibig sabihin na yan, operating in reverse? So nakita nyo dito sa picture, sa previous nating discussion, class, ang arrow dito sa taas pababa, right? Tapos ang arrow dito sa baba pababa din. But this time for refrigerators, ang process is reverse. No, Q hot palabas siya, Q cold papasok, then work papasok din. Okay? So work is done on gas, extracting the heat from cold reservoir and depositing heat into the hot reservoir. So ito yung concept ng refrigerators. So the formula for refrigerators is the work input or in plus Q cold equal to Q hot. Okay, so na-reverse yung formula, class. Sorry, work input equal to Q hot minus Q cold. So second law for refrigerators. So it is impossible to construct a refrigerator that absorbs heat from a cold reservoir and deposits equal heat to a hot reservoir with delta W equal to 0. So impossible daw yan mangyari, class. So here, if this were possible, then we could establish perpetual motion. Kung posible lang sana to, mangyayari yung perpetual motion, but it won't because there are losses. So hindi talaga mangyari yan. Now, next is the coefficient of performance. So the coefficient of performance, we call it COP, and represented by the letter K. So the COP of a heat engine is the ratio of the heat QC extracted to the net work done, which is W. Or K is equal to QC divided by W. And we know that W is QH minus QC, so therefore this is equivalent to QH over QH minus QC. So for an ideal refrigerator, we have K equal to TH over TH minus TC. So yan yung coefficient of performance. Ideal yan na refrigerator, class. For example, no, a Carnot refrigerator operates between 500 Kelvin and 400 Kelvin. It extracts 800 joules from a cold reservoir during each cycle. What is the COP, W, and QH? Okay, so using the formula, substitute the values. So we got K equal to 40. Okay, then solve for W. So next we'll find QH. QH muna pala. So finding QH by assuming same K for actual refrigerator or Carnot. So K is equal to QC over QH minus QC. So substituting K, therefore we can solve for QH. So QH is equal to 1000 joules. So solve na natin QH, then using the formula that involves work. So we have, so dyan mo makikita sa ano yan, class, ha? Dito sa, if you don't know where this formula is coming from or relationship coming from, nandito lang yan sa illustration natin. So papasok yung work, so positive siya, palabas tong isa hot, then yung cold papasok. Okay, so you have work equal to 1000 joules minus 800, so therefore work is equal to 200 joules. Alright, any questions so far?
Wala po.
Okay, so let's proceed. Next is summary. So patapos na tayo class for this topic. So ito yung summary class. The first law of thermodynamics. So the net heat taken in by a system is equal to the sum of the change in internal energy and the work done by the system. So in formula, we have delta Q equal to delta U plus delta W. Ang delta natin class is the final minus initial. Okay? So, yun yung summary ng first law of thermodynamics. Then, we have four processes. The first one is the isochoric process. So, delta V is equal to 0 and delta W is equal to 0. Next is isobaric process. Delta P is equal to 0. And the isothermal process, delta T equal to 0 and the delta U is equal to 0. No change of internal energy. And finally, adiabatic process. So we have delta Q is equal to 0. So that's why we have delta W equal to minus delta U for adiabatic process. Okay? So for molar specific heat capacity, C, so units are joules per mole per Kelvin degree. That is given in this formula. Okay? And the following are for the mini processes. Sorry, the following are true for any processes. So delta Q equals delta U plus delta W. So this can be applied. There are four processes class. So for any of the processes of thermodynamics, we can use this formula. We can use also the PAVA over TA equal to PV VV over TB formula. And delta U equal to N CV delta T. And for the ideal gas, we have PV equal to N RT. So take note when you use these formulas, take note of the units. You have to be consistent. Again, for the second law of thermodynamics, as mentioned, it is impossible to construct an engine that, operating in a cycle, produces no effect other than the extraction of heat from a reservoir and the performance of an equivalent amount of work. So, not only can you not win the first law, you cannot even break even the second law. So, ito yung reality class about these heat things. Okay, so the efficiency of a heat engine is given by this formula. A equal to 1 minus QC over QH. The other formula is 1 E equal to 1 minus TC over TH. And the coefficient of performance of refrigerator is given by this formula. K equal to QC over work input equal to QC over QH minus QC. And K equal to TC divided by TH minus TC. And in conclusion, so thank you very much. I hope you enjoy our lesson today, and I'm hoping that you are doing your assignment. So expect another assignment class from Wiley. All right?
Thank you, sir.
Okay, so let's go to the anong oras na ba class? By the way, have you studied the video that I sent to you? Abutal? Abutal present? Absent?
Present.
Bathan?
Present, sir.
Kuraming? Kuraming absent? Di Castro?
Present po.
Junida?
Present po.
By the way, class, when I call your name, you type also your name in the screen para ma-double check ko. Junida?
Present po.
Okay. Reyes, Gandisila.
Present po.
So type your name. When I call your name, type your name also on the screen. Judy, Samuel. See present and then type your name. Irish, Hunyo.
Present, sir. Present po.
Okay. Mercado.
Present po. Present.
Type your name, Mercado. Panahon. Panahon? Absent si Panahon. Perez. Perez absent?
Present po.
Sige, type your name.
Type na ba?
Type again, hindi ko nakita. Ras.
Present po.
Okay, type your name. Type again kasi hindi ko nakita. Reyes. Pag magsabing present class and then hindi mag-type, hindi yan present ha. Kailangan dalawa yung makikita ko. I mean, I need to get two information from your voice and from the screen. Ras, type your name, Ras. Reyes. Wala ha, wala. Pag walang sumagot, wala yan. Rojas. Class, can you still see the screen?
Yes, sir.
The attendance, can you see the attendance screen?
Hindi po. Yung ano po, yung PPT po yung nakikita namin.
Ngayon, nakita mo na?
Okay na po.
Okay.
Present po.
So I need to see your names ha. And when you say present, I need to see your name also. Type Sanchez.
Present po.
Okay, type your name.
Wait. Sir, yung sa baby collab pa po ba? Mag-type pa po ng name.
Oh, doon ka sa collab magta-type. Sa collab kayo magta-type. Kasi nakikita na yan dito. Santiago, absent? Santiago?
Present po.
Oh, type your name.
Wait lang po.
Sige. Silitaria.
Present po.
Oh, type your name, please. Silitaria, type your name.
Okay na po.
Wala pa secretary, hindi ko nakita yung name.
Ay, ulit.
Okay. Tanhui ko.
Present po.
Malapit na tumatapos ha. Continue lang sa ano. Pag di nyo na ako nakita, continue sa BBL. Tanhui ko, type your name please. Velasco.
Present po.
Type your name. Orbina. Vidal.
Present po.
Vidal. Type your name please.
Present po. Present po.
Sige, type your name. Type your name. Hinihintay ko yung pag-type ng pangalan mo. Doon sa BBL. Kung maputol tayo, diretso tayo sa ano
Okay
ha.
na po natin.
Continue lang doon sa BBL.
Okay na po, sir.
So Orbina. Orbina.
Present po.
Type your name, Orbina. Tanhui ko, type your name also. So, tingnan nyo to ha. Baka may hindi na ano, sa video na ipopost ko, tingnan nyo yung pangalan nyo doon. Present ba kayo absent? Orbina, I didn't see you. Tanhiko.
Sir, wait.
Na, malapit na tumaputol. Okay, look at the screen ha. Tingnan nyo kung na present kayo absent. Nandyan ba si Reyes? Yan, hindi ko nakita. Pakiulit.
$533 po nakalagay. John Marie Emmanuel Reyes po.
Tanhiko, nandyan ba Tanhiko? Okay, I got it. Orbina. Si Orbina. Kuraming. Si Orbina. Okay, tapos na lahat, class?
Sir, di daw po makakonect sa BBL si Urbina daw.
Nako. Paano yan?
Pero andito po siya, nag-type po siya sa Zoom po.
Nag-type siya sa Zoom. Sige.
Oh,
Nag-type siya sa Zoom.
after ko po, the last ko po.
Wala man si Orbina dito. Wala na.
Urbina, present.
Orbina. Where's Orbina? Wala din siya dito. Okay, class. Thank you very much. I'll have another class after this. Okay, si Abutal. Reyes. Okay, Reyes. Sino pa? Check your your names kung absent or present kayo. Anyway, ipopost ko naman to. I-double check nyo lang ninyo ha. Just let me know kung may discrepancies. Si Rojas, absent talaga to si Rojas. Di Castro. Sino pa? Okay. Okay, class, look at the screen. Sa panahon, nandiyan ba sa panahon?
Wala po si panahon, sir.
Absent si Panahon. Okay.
Yes, sir.
Okay, so I think that's all, no? That's all for today. And please study the slides, huh? And watch the video. Did you watch the video that I posted? Pag-aralan nyo, class.
Kaya nag-ano po ulit si Orbina mo. Dito po sa Zoom.
Nasa Zoom na?
Um,
Okay, Orbina.
Hindi nag-preso.
Mapuputol na to, class, ha, in few minutes. Okay, thank you very much, class.